Okay, so this is a continuation of week 3 lecture notes. We're still talking about statistics, and we are on slide number 4 here. So these problems here dealing with percents, I like to solve them using a proportion. And there's a little kind of saying here that to do when you to set these up, and it's is over of. Okay, is over of. Okay. So in this case, so I'm looking at part A here. All right. And so again, a proportion, remember, is just two fractions that are equal to each other. All right. On the top right here are on the right column is the percentage, and then you have your is over of. So is over of. Okay. So and then the bottom right here is always 100% every time. Okay. So when we look at the first one, it says, what number is 95% of 60? Okay. What number is 95% of 60? So the 95%, right, is dealing with the percent column, and this is on the top. So I'm going to put 95 over here. Okay. And there's of 60. So of 60 is on the bottom. So I'm going to put 60 there. Okay. And then I just put X on my top because I'm trying to figure out what that is. What's the number? What number is 95% of 60? Then I just cross multiply, okay, and divide. So remember, cross multiply is the butterfly move. So I multiply these guys together, and then I multiply these guys together. Okay, so I get 100x equals 60 times 95. Then divide both sides by 100. Okay. And then I get 57. Okay. All right. Again, do you have to do it this way? Absolutely not. You can do it whatever, again, works with your brain. And then part B, I'm going to do exactly the same thing. Okay. So again, I set up my proportion. Okay. Anything with the percent. All right. I put on the right column. And then I have is over of. All right. And then I have 100 here. All right. So in this case, so we have 55% of what is 22. 55%. All right. I put that right here. And it says of what? I don't know. Okay. So of what? Of is in the bottom. So I'm going to put X there. And it says is 22. So 22 goes there. Okay. So I cross multiply again and divide. And when we do that, we get X is equal to 40. All right. So there's an answer there. Okay, someone asked about if there was an alternative method, and so I showed that here by using algebra. So I let x, what number is x, is an equal sign, and then 95% will be 0.95 of translates to multiplication. So times 60. So we just do 0.95 times 60, you get your answer. Uh, Actually, what you need to do is, hold on a second here. Okay. I rewrote 57, wrote it backwards. Anyway, it's 57 here. And then part B, same thing. So 55% of what? So that translates to 0.55. Of is times what? X is 22. And then you solve for X. All right. So again, whatever method works for you in your brain, that's fine with me. Okay. All right, this part C here says an item on sale costs 15% of the original price. The original price was $75. Okay, so this one I'm going to show two ways as well. So one is again doing the proportion. And when we start working on compound interest and things like that, that's going to be really helpful, especially when we do also exponential functions. So that's why I'm doing it this way to kind of just train your mind to think about it in these terms. Okay. So um, when it's talking about a percent increase, okay, when it's talking about, let me use a different color here. When it's talking about a percent increase, okay, you're going to add you're going to do 100%. You're going to add to the 100%, okay? So 100 plus the percent, okay? If it's dealing with percent decrease, okay, you're going to subtract from the 100%, okay? So what do I mean by that? So again, I'm going to set this up as a proportion. So I'll do it here, right? So again, anything on the right column is going to be dealing with the percent, and I always have 100 here. Okay, so here it says an item on sale costs 15% of the original price. So that translates to I need to deduct from the 100%, right? 15% of the original price. So that means I'm going to be subtracting from the 100%. So I'm going to do 100 minus 15%, and I will put 85 here. Okay. And then the original price was $75. So that means that's going to be like the overall price. That's the of part of the equation. And then I'm trying to figure out, okay, what is that sell price? So that's going to be my X. Okay. So again, I'm just going to cross multiply and divide here. All right. So I'm going to multiply these guys together and multiply these guys together. So we're going to have 100X equals 75 times 85, then divide by 100. Okay. All right. And that gives us $63.75. Okay. So that's one way. Again, I'm doing it this way because when we do the compound interest and exponential functions and things like that, it's talking about percent decrease and percent increase. And it's just training your mind to think in these terms. Now, okay, so and then another way, right? Alternative way, the different color here. Okay, spending too much time on this one. Okay. So alternative method. Okay. All right. Questions on that? Okay, let's jump to slide 14. I know we talked about this a little bit, but I just wanted to emphasize a particular part on here. Let's go to slide 14. Okay. I don't know why it keeps moving like that. Okay. You can always zoom in on your end. All right. This is slide number 14. Okay, thank you to those who have submitted their answers. Looks like for A, a lot of people are choosing the mode. For B, we're getting mostly people are picking the mean. And then for C, we're getting a mix between median and mean. Okay. Okay. So remember the mean is the average, the median is the middle number. Make sure that you put that in order from least to greatest. And then you pick the middle number of two numbers are in the middle are the same, you have two numbers in the middle, then you take the average of the two, and the mode is the number that occurs the most. You can have more than two modes, okay? You can have more than one mode, okay? So, um, or you can have no modes at all. So for part B here, as I already mentioned this, but whenever you have an outlier, the number that's way out there, you never want to pick the mean because it's going to skew the data. You always want to pick the median, okay? And then for this one, part C, um, there's no number that's occurring the most. Everything is kind of represented equally. So you just take the average of these numbers. So the best representation of this one will be the mean. All right. It says here a sample of 33 customers was taken at a local computer store. The customers were asked the prices of the computers they had bought. The data are summarized in the following table. So here on the first column, you have the number of computers, and here in the second column, you have the price in dollars. So if you think about this, so it's telling us that there are six computers that are $900 a piece. So if we were to write this out, right? We'd write down $900 six times, right? So 900, 900, 900, 900, 900, 900. Okay. And then for the $1,600, you would write it 12 times. Okay. So that would take some time. And then for the $1,000, you would write it 15 times. Okay. Again, that would take some time. So And to find the average, you would add up all of those prices and then divide it by the number of computers. Okay. So that's one way of doing it. But again, that's going to take a long time. So what if you had 100 of those computers and 200 of those $1,600 computers? So again, it's going to take you a minute to do it. So what's another way? Well, this is similar to what we did. Actually, it's the same thing that we did when we did the weighted average last time. So what you're going to do here is you're going to multiply each of these rows, okay? And then you're going to divide, once you get your total for each one, you're going to add them up, and then you're going to divide it by the number of computers, all right? So your first step here is to multiply these out. So when we do that, we get 5,400, 19,200, and 15,000, okay? All right. Once we multiply those, then we're going to add these guys up. So it's step number two, we're going to add them up. Okay. Add up. So when we do that, we get 39,600. Okay. And then step number three, we're going to take the 39,600 and we're going to divide that by the total number of computers we have. So when we add up the computers here, we're going to have 33. Okay. So we take $39,600 and then we're going to divide that by 33. Okay. So when we do that, we get an average price or a weighted average price of $1,200. Okay. All right, so this one says Rise Corporation is contemplating on using a new, more expensive glue in the construction. of laminated veneer lumber. Of importance to the company is the carrying load of the lumber. The company has tested 29 beams using the new glue, recording for each beam the pressure in pounds per square foot at which the beam breaks. The data collected are presented in the following frequency distribution. So here, and that's kind of hard to see, but again, I give you a copy of this. Um, the first column here is the carrying load, and it's in pounds per square foot. And then the second column here is the frequency. Okay. So it's based on the frequency distribution using the midpoint of each data class, estimate the mean carrying load of the beams tested. For your intermediate computations, use 4 or more decimal places and round your answer to 1 decimal place. Okay. So make sure you do that, especially in the program, right? You use 4 or more decimal places and round your answers to 1 decimal place. Okay. So as I mentioned, this is the carrying load, carry load, and this is the frequency. Okay. Right. So the key word here is midpoint, right? The key word here is midpoint. So what we need to do is we need to create another column um, based on the midpoint. So guys, we want to estimate the mean carrying load of the beams. So let's put the midpoint column here. Okay. So again, to find the midpoint, we talked about this before. We just take these two numbers, the 860 plus 879 and divide it by 2 to find the midpoint. So when you do that, you get 869.5. Okay. So that's 869.5. Then we're going to do that for every carrying load interval. Okay. So the second one, when we do that, we get 889.5. The third one, we get 909.5. The fourth one, we get 929.5. And the last one, we get 949.5. Okay. So then after we find the midpoint for each of the carrying load intervals, then we're going to multiply that by the frequency because that's telling us how many times, it landed within that carrying load. So we're going to multiply these guys. Okay. So when we do that, we get 4347.5 for the first one, 6226.5 for the second one. We get 10914 for the third one, 3718 for the fourth one, and then 949.5 for the last one. Okay. Once we multiply those, then we're going to add them up. Okay. All right. So then the total here, okay, that's going to give us 26155.5. Okay. And then we're going to divide that by the frequency. Okay. The total number of frequency. So we need to add these guys together. Well, they told us it's 29, but if they didn't tell us we would add these together, we would get 29. Okay. So we divide these together. And so we get about, because it wants us to round to 1 decimal place, right? So that's going to give us 901.9 as our answer. All right, this is slide number 15. It says, in a recent survey, 8 people were each asked the number of times they have been on the plane. Here's a list of the responses. Find the range of the data set. Okay. The range of the data set, all you have to do for that is you just take the max or the highest number, and then you subtract from the lowest number. Okay. So in this case, the highest number here is 26. And then the lowest number we have is 9. Okay. All right. So then the range will be 17. Okay. So here it says, here are yesterday's high temperatures in Fahrenheit in 11 US cities. Notice that the temperatures are ordered from least to greatest, which is great, so we don't have to order them. Give the 5-number summary and the interquartile range for the data set. All right, so here we have the 5-number summary. So we have to provide this information and then calculate the interquartile range. So as we look through this, right, it's already ordered from least to greatest, which is great. Again, if it wasn't ordered from least to greatest, then we have to put them in order first. Okay, so and looking at these numbers, the minimum number is going to be 54. Excuse me. And then the maximum number there is going to be 83. Okay. All right. So now let's talk a little bit about this lower quartile, median, upper quartile. So another way to write or say lower quartile is Q1. Another way to write median is Q2. Another way to write the upper quartile is Q3. Okay. And I'll explain what that means later. So, so again, step number 1 is we want to put this in order from least to greatest. If you don't, you're not going to have very good results. Okay, from least to greatest. Step number 2 is we want to find Q1, Q2, and Q3. Okay, so you want to start off with Q2 first, and then you go off the Q1 and Q3. Okay. Now, once you use that number for Q2, then you can't use that number anymore to find Q1, okay, or Q3. Okay, so what do I mean by that? So again, we're looking for Q2, right? We're going to start here first. We're going to find the median, okay? Okay, so here again, this is order from least to greatest, and we find the middle number. So we start, marking these off at each end to find the middle. Okay, so I got 5 crossed off on the left, 5 crossed out on the right, and I find my middle number, 67. Okay, so that's going to be my median. Okay, that's also represented as my Q2. Okay, so let me erase this here. Okay, so again, we found our median, so we write that down. So 67 is our median. Okay, so now I need to find the Q1 or the lower quartile. Okay, they interchange these words. So I already used 67 as my actual median number. Since I use 67 as my actual median number, I can no longer use that number to find Q1. So that means the numbers that I can use are the numbers that are on the left of 67. Okay. Okay. So in this case, I do the same thing. I find Q1. And that's just going to be, excuse me. Okay. So that's just going to be again, the middle number here, or the median, right? So again, we cross these guys off on each side, and then we find the median here, or in this case, the lower quartile, or Q1. So that's going to be 57. Okay. Then I do the same thing for the upper quartile. Again, I don't use 67 because I already used that. Then I use the right side here, and I cross those guys out. to find the Q3 or the median of the right side of the numbers. So that would be 82. Okay. All right. So this will be our 5 number summary. Okay. So make sure you complete that. The next part is the interquartile range. The interquartile range is used by using this formula. You just take Q3 minus Q1. Okay. You take Q3 minus Q1. So Q3 was 82. Okay. That was Q3. And then Q1 was 57. Okay. So 82 minus 57 is going to give us 25. So our interquartile range is going to be 25. Right? Okay. Let me pause there. Okay. I know that it doesn't ask this, but on your test, it's going to ask this, and we'll do a problem that's going to ask this. So once we find the 5 number summary and then we find the interquartile range, okay, the last thing we need to do is we need to find the box and whisker plot. Okay, what is that? Well, we're going to use the information that we got and we're going to translate that or transfer that to drawing this graph here. Okay, and you'll see what I mean when it says box, why it's called a box and whisker plot. So how do we do this? So first, again, you want to um, um, draw your points, okay? Or label your points. So in this case, 54 was our minimum, so that's going to be between 50 and 60, so closer to the middle number here, right? So I'm going to put a point there, right? And I'm going to label that. That's my 54. So make sure you do that. So I know what that point is. And then I'm going to go to 57. Again, it's still between 50 and 60. So maybe it's right here. Put a point there. So that's 57. And then our median is 67. So it's closer to 70. So I'm going to put a point there. And then 82 is upper quartile. So that's closer to 80. So above 80. So put a point there. And then we have 83 maximum. So that's right next to it. So that's 83. Okay, so that's the first thing you want to do is you want to plot those points, okay, and then label them. Okay, once you do that, now you can draw your box. Okay, the box, I'm going to use a different color here. Okay, so I'm going to put a line in the middle, another line here, and another line here. Okay, and then I'm going to connect those lines. Okay. So this is my box. This is why it's called the box. This is the box that they're referring to. Okay. And then whisker. What does that mean by whisker? So then I'm going to extend. Okay. I'm going to put a whisker or a line connecting 57 to 54. Those are the whiskers it's just talking about. Okay. These are the whiskers. Okay. Think about a cat. All right. So okay, so it's pretty easy. You can plot those numbers that you found from the 5 number summary, draw your box, and then the whiskers. And this is your box and whisker plot. Okay. But again, this box and whisker plot is only going to be correct if your 5 number summary is correct. So if your 5 number summary is not correct, then the box and whisker plot is not going to be correct. So the next part I want to talk about regarding this problem is the outliers. I know it doesn't ask this, but again, this will be on your test. Don't worry, we'll have a problem that asks all of these questions, but I'm trying to um, get your mind thinking. So how do we find the outliers? You can't just say, oh, that number is an outlier, okay, or that number is an outlier. So there is a formula for that, okay, to determine what the outliers are. So that's what I'm going to discuss next. So, so outliers. So again, I would write this down if I were you. So what are outliers? Okay, so that's the number that's going to mess up your data. Okay, you're going to have what's called the lower fence, and then when you're going to have what's called the upper fence. Okay, so the lower fence is going to be Q1 minus 1.5 times the IQR. And then the upper fence is going to be Q3. So again, see the difference? I have Q1 for the first one and Q3 for the second ones. A lot of students use Q1 for both and they messed up on that. And this is going to be added instead of subtracted. Okay. All right. So again, the lower fence, you just do Q1 minus 1.5 times the IQR. The upper fence, you take Q3 plus 1.5 times the IQR. So again, we're going to use the same data that we had before, okay? So for our Q1, right, our Q1 was 57 and our Q3 was 82. So let's write that down. So Q1 was, we use a different color here. Okay, was 57 and our Q3 was 83. Double check that. Nope, 82. Okay. All right. And then now we're going to subtract 1.5. Again, this is just the formula. And then the IQR. I think the IQR was 25. Yep. So our IQR was 25. Okay. That's the interquartile range. So I'm going to multiply this by 25. Okay. And then the bottom where I'm going to add the 1.5 times the 25. Okay. All right. So when we put this in the calculator, we get 19.5 for the lower range or the lower fence, and then we get 119.5 for the upper fence. Okay, so, what does this mean? That means that the lowest number that we can go that is not considered a outlier is 19.5. And then the highest number that we can go that's not considered an outlier is 119.5. So once we pass these numbers, we go below 19.5 or we go above 119.5, those numbers are our outliers. Okay. So again, let me repeat that one more time. What do these numbers mean? 19.5 means that's the lowest number that we can go in our data, and it will not be considered an outlier. Anything past that, anything below 19.5 will be an outlier. And then so it is with the upper fence. The highest number we can go that's not going to be considered an outlier is 119.5. Once we pass that, above that number, then any numbers above that is going to be an outlier. Okay? So remember that. So in this case, you know, 54 was our lowest number, so there's no numbers below that, so we don't have an outlier for the lower end. And then 83 was our highest number, right? It does not surpass 119.5, so that means we don't have an outlier for the upper end, okay? So in this case, if it did ask for what, do you have any outliers, then you would say no, okay? But unfortunately, this question is missed a lot because students don't figure it out, don't calculate this. You need to do this. So I put a big star in that if I were you. You need to do this and show that it doesn't have any outliers. You can't just look at the data and say, oh, it doesn't have it. Okay, how do you know that? You have to show this part here. Okay, but again, this question is missed a lot. All right, any questions here? Let me pause this. Okay, so for this particular problem, we're going to do the same thing as we did before. Okay, so we're going to find the five number summary, the IQR, right, the interquartile range, um, are there any outliers, and then the box and whisker plot. Okay, so again, this is a loaded question, has a lot of parts to it, but that's what we're going to do here. Okay, so So you have this data set that you're dealing with, and you're going to be answering those questions again. All right. So it's going to be the 5 number summary, the interquartile range. Um, are there any outliers? And then the box and whisker plot. All right. So this problem, it says there are dozens of personality tests available. One test is designed to give an indication how personable the test taker is, with higher scores indicating more personability. Suppose that 18 classmates have taken this test and scored as follows. Okay, and we need to find the following. All right, so we needed a 5 number summary and also the IQR, the outliers, and then we have to do a box and whisker plot. So number one, remember the first thing we need to do is we need to put this in order from least to greatest. Okay, and I've already done that here. All right, and then we start just you know, answering these questions. So the first thing you want to do is you want to start with Q2. Okay, that's the most important part. So when we try to find the middle number here, notice that we're going to have two of them. All right, that's going to be 65 and 70. So let me use a different color here. Okay, so we have 65 and 70 are our middle numbers. So we need to take the average of the two. So 65 plus 70 divided by 2. Okay, we're going to get 67. Let me rewrite that. So 65 plus 70 divided by 2. That's going to give us 67.5. Okay, so hopefully you wrote that down. So that's going to be our Q2. So that's the most important number we have to do first. Okay. All right. So we write 67.5. Now, since we didn't use the actual number 65 or 70 as our median or as our Q2, then those numbers are free for gain. That means we can use those numbers again. Okay. So what am I saying? So that means that these numbers to the left, okay, I can still use, right? So that means the number 65 I can still use. All right, so I start marking them off. So 1, 2, 3, 4, 1, 2, 3, 4. Right? So in this case, 62 is going to be my Q1. Okay, so I'll write 62 here. All right, then I do the same thing for the right side. Okay, so again, I can use 70 again because I did not use that as the actual Q2 number. So mark these guys off. 2, 3, 4, 2, 3, 4. Okay, so 77 is going to be our Q3. Okay. Oops. All right, and then our minimum number is 50 and our max number is 85. Okay. All right, so now we need to figure out the IQR. So remember the IQR is just a Q3 minus Q1. So that's going to be 77 minus 62, which gives us 15. And then the outliers, remember you have the lower fence. I'm just going to label that LF for lower fence. And then the upper fence, I'm going to label that as UF. All right, so that's going to be Q1 minus 1.5 times IQR. And then the upper fence is Q3 plus 1.5 times the IQR. Okay. All right. So for the upper fence, we get, I'm sorry, the lower fence, we get 62 minus 1.5 times 15. So that's going to give us 39.5. For the upper fence, we get 77 plus 1.5 times 15. So that's going to give us 99.5. Okay. All right. So when we look at our data here, right, the lowest number we have is 50. Okay. So in order to be a lower fence has to be lower than 39.5. So we don't have a lower fence, right? Or an outlier for the lower fence. In the upper fence, the highest number is 99.5. Has to be bigger than 99.5. Our highest number is 85, so we don't have an upper fence outlier. Okay? So in this case, we have no outliers. All right. Now, our last item we have to do is draw our box and whisker plot. Okay? So we draw a line here. Let me move this line up a little bit. All right. And you just have to figure out, okay, these are the numbers that I have. Okay, what will be the best way to represent those numbers? Sometimes maybe you're going by twos, maybe by fives or tens, whatever is going to best represent your data. So in this case, I'm going to go by fives. So I'm going to start out with 45, and then 50, 55, 60, 65. Again, it's really hard to write on this. 70, 75, 80, 85, and then 90. Okay, so I'm just going to go by fives here. All right, so again, the first thing is you need to plot your points. So my lowest point is 50, so I'm going to plot that there, and I'm going to write 50. And then my next point is 62, so that's between 60 and 65. So I write down 62 here. The next point is 67.5. So that's between 65 and 70. So I write 67.5. The next one is 77. So it's about right here. And then the max is 85. Right here. Okay. So again, make sure you do label these points. If you don't, you will lose points. Okay. All right. So then I'm going to draw my box. All right. So I draw one here, one line here, draw one line here, and draw another line here. All right. And then I just connect those lines. Okay. And then I draw my whiskers. And there's your box and whisker plot. All right. There is one more thing I do want to point out. So let's say that we do have an outlier. What do we do? Okay. So let's say we have another number and the number was, 100. Okay. So I'm going to write it in pink. Okay. So let's say we have a 100 was the highest number that was on our list. So what's going to happen with that? So if it is an outlier, right? Because this is above 99.5, okay? So when you draw this on the box and whisker plot, okay, you're just going to, label the number that's 100, and you're going to label it like that. And you're going, instead of putting a dot, you're just going to put an asterisk, just like that, okay? And that indicates that that is an outlier. So if it did extend out to here, okay, then you would remove that line. You would remove that line and your whisker will go to 85 instead of 100. Okay. And then at 100, you would just draw the asterisk to indicate that that is the outlier. Okay. So for this next problem, we need to make a note of these rules first. All right. So it says here, rule number one says if n times p over 100 is not an integer, round it up to the next integer. This position is the pth percentile, okay? If n times p over 100 is an integer, calculate the mean, the average in this position and the next position. This will be your pth percentile. All right, so what does that mean? So the best way to understand these rules is by doing a problem. So let's go to, I think it's this. Nope. Yep, this is it. Okay. All right. Says the weight in pounds of 16 preschool children are listed below. We want to find the 25th and 70th percentiles of these weights. Okay. So the 25th percentile, that's going to be easy. That's our Q1. So in fact, you know what? Let me go back here to our previous problem and let me explain something real quick here. So the reason why they're called quartiles, right? So think about a dollar, right? How many quarters are there in a dollar? There are four quarters. So this box and whisker plot is broken up into four parts or four quarters. That's why this one where 62 was is Q1, is quarter one, whereas 67.5 is Q2, that's quarter two, because one, two. Whereas 77 is that's Q3, quartile three. All right. So anyway, this box and whisker plot or this data that we have is broken up into four parts, and that's why these are listed as quartiles or termed as quartiles. So the 25th percentile, that will be referring to Q1, the 50th percentile, right? So Q1 here, that's going to be the 25th percentile. Q2 is going to be your 50th percentile, and then Q3 is going to be your 75th percentile. Okay, so that's 25. So remember that. Let me rewrite this part here. Okay, so again, just another way to describe the same information. 25th, 50th, 75th. Okay, so the 25th we know how to do. So let's do that. Now I know there are two ways that you can do this. Okay, one that I'm showing to you, and another way is what Alex would show. Okay, and Alex, sorry, the program is going to mark them correct, either which method you use. So FYI, I know there are two ways of doing it. And the way I'm showing you, the program is going to accept, and the way the program is going to show you is another way it's going to accept. Okay? Okay, here we go. All right, so again, the first thing we need to do is we need to list these numbers from least to greatest. All right, so let's go ahead and do that. So let me pause here for a second. Okay, so again, the first thing we need to do here is we have to order this from least to greatest. I've already done that. Okay, so again, there's 16 items, so we should have 16 listed here. And then make sure, double check, triple check that you have written the right numbers here. Okay, so the first thing we want to do is we want to find the 25th percentile. Okay, so think about, remember, percentile, that just means remember back in grade school, they always tested you guys a lot in regards to, where do you rank among your peers in math, science, writing, whatever it is. Maybe you did really well and you were at the 99th percentile or 95th percentile. So that means that, you did better than 95% or 99% of the students that took the same test. Maybe you didn't do so hot. Maybe you go in the bottom range. Maybe you're in like the 40th percentile. That means that, you did better than 40%, but yet there's 60% people that did better than you. Okay. So that's what the percentile, that's what they're referring to. And that's what's going to be important. in later on, okay, in regards to the percentile. Anyway, so so to find the 25th percentile, we need to find the 50th percentile first. Okay, so basically Q2. So so Q2 in this case, just to maximize our time here, it's going to be these two numbers here, right? There's two numbers are in the middle. So we just take the average of the two. And when we do that, we get 33.5. So that's going to be our Q2. So again, we didn't use 33. So that number is still up for grabs. So then we just start marking off um, for Q1. So I have three here. And again, I have two numbers that are in the middle. So I'm going to take the average of those two, and that gives us 23.5. Okay. So this is going to be our 25th percentile, or this is Q1. Okay. So we found the 25th. But now, how do we find the 70th? We know how to do Q3, right? But the same process as we did for Q1. But how do we find it when it says the 70th percentile? Okay, it's not so easy. So what we do is we need to apply this formula here, or the rules here. So we need to do n times p over 100. That's what we have to do first. So that's going to be the number of items times P, okay, over 100. So the P will be the percentage. So let's go back to here. So again, we want N. So again, I'm looking for the 70th percentile. That's my goal. So we're going to use the formula N times P over 100. Okay. So N is the number of items we have, which is 16. And then we're going to multiply that by P over 100. So P in this case is the 70th percentile, so 70. So 70 over 100. Okay. All right, so when we put this in the calculator, we're going to get 11.2. So what do we do with that number? Well, let's go to the rule. Okay. It says if it's not an integer, okay, integer is like 1, 2, 3, 4, -1, -3. Those are integers. It's like the number line, okay? If it's not an integer, then we need to round it up to the next integer. So in this case, 11.2 is not an integer. So that means we need to round up to the next integer. So in this case, the next integer is going to be 12. Okay? So we want the 12th position. All right, so let me restate that. 11.2 is not an integer. So based on the rule, we need to round up. I know that, goes against what we know about rounding, but we need to go up, go to the next, okay? And then that will be the 12th position. So what does that mean? That means we go here and we count, okay, from left to right, okay, and whatever is the 12th position, okay, that's going to be our 70th percentile. All right, so when we count, right, we count from left to right. So 20 will be number 1, 21 will be number 2, 22 will be number 3, so on and so forth. And we find out that 43, okay, this is going to be the 12th position. All right, and this will be the 70th percentile. Okay, so let's say for rule number 2, it says, if it is an integer, right? If our result was an integer, so instead of 11.2, it was 11, all right? So if it was an integer, so 11 is an integer. So this is for rule number 2. What do we do? So we go to the 11th, right? The 11th position, which is 39. This will be the 11th position. And then it says here, we go to calculate the mean or the average in this position and the next position, and this will be your pth percentile. So in this case, we would go take the 11th position and the 12th position. We take the average of the two, okay? So we would add those guys up. So 39 plus 43 divided by 2 is 41. So we take 39 plus 43 divided by 2, and we would get 41, okay? And so that would be the 70th percentile, okay? If it was an integer instead of a decimal number. All right, so this next slide, this is going to prepare us to calculate the standard deviation, but we need to understand what this symbol means. Okay, it says the following is a list of 5 measurements, all right? And suppose that these 5 measurements are respectively labeled x1, x2, all the way to x5, okay? So order doesn't matter here. So in this case, this will be 17 would be your x1, 8 will be your x2, 13 will be your x3, 17 will be your x4, and 18 will be your x5, right? So that's what it's saying. It's a subscript. It's identifying that, which number is the first x, the second x, and so on and so forth. Okay. All right. Now let's talk about this symbol here. So this symbol here, okay, is called summation. All right, so this little Greek letter E is summation. So it's telling us that we're going to start at 1 and then we're going to end at 5. Okay, we're going to start at 1 and end at 5. And that's true here, right? Because we have 5 numbers. So we're going to start at 17 and then we're going to end at 18. Again, order doesn't matter here. Okay. All right. So what are we doing with those numbers? Well, this is what this formula is telling us, right? So this is an I down here. That just means ith, or in this case, it was representing I is equal to 1. All right. And so it's telling us, okay, we want to take the first number that we have and we need to square it. That's what this is saying. All right. So in this case, I'll take the first number that we have, so that's 17, and then we square it. Okay. All right. So, but this is summation. So that means we need to add them. So then we're going to go to the next number, 8. All right, and square that. And then we continue on, right? Take the next number, 13, square that. Take the next number, 17, square that. And take the last number and square that. Okay, all right. All right, so once we square each number and then we add them up, all right, we should get a total of 1135. Okay, so that's our answer there. All right, here it says the Tourist Bureau of the Hawaiian Islands surveyed a sample of 5 United States tourists as they left to return home. The tourists were asked how many days they spent on their visits. Their responses were as follows: 9, 7, 6, 10, 8. Find the standard deviation of this sample of numbers. Okay. All right, so standard deviation, we're going to talk a lot about that in the next lesson, but standard deviation means you have your particular standard and how much does it deviate from the standard, or in the case, from the mean. Okay, so that's basically what standard deviation means. How much is it deviating from the mean? So how do we calculate that? So we need to learn how to do this on the test. So we are going to be using this formula. All right, and don't get scared. This is the standard deviation. And there's actually 2 types. And we're just going to learn this type, and this is for a sample. There's another one for population. So we're just going to do the sample version. Okay. All right. So what you do is um, on the top part, you're going to take the summation. Okay. And it's going to go from I is equal to 1 to n. And then you're going to take xi, so your number that's given to you, minus x bar. Okay. And the x bar means the average. And then you're going to square that. Okay. So this bar here means the average. Okay. And the xi here is representing the number given to you. Okay. The number given to you. All right. So that's going to be in the numerator. That's going to be on the top. Okay. And then the denominator, we're going to have n minus 1. So the n here is going to represent the total number, or the total items, I should say, that they give you. Okay. All right. And then minus 1. All right. So that's all going to be under the radical. Okay. So this is all going to be under the square root or radical. Okay. All right. So I'm going to show you one way to do this, and the program is going to show you a different way. It doesn't matter which way, whatever works with your brain. I'm going to do it this way because it helps people to process it, doing it step by step. If you want to go do it all in one lump sum, that's totally fine. Okay? So again, there is a reason why I'm doing certain things, because it helps people to process the information by going step by step. But again, do you have to do it this way? Absolutely not. You can do it the other way that the program has laid out. All right. So what I'm going to do here is I'm going to create a table. Okay. So the first part, I'm going to have xi minus x bar. Okay. And the second part, I'm going to have xi minus x and x bar, and I'm going to square it. And then I'm going to have the results. Okay. So this is going to be my table. Okay. So first we need to find the average. We know how to do that, right? So we just take all these numbers here. So we're going to have x bar. Okay. So we're going to add up all these numbers. Okay. And then divide them by 5. All right. So go ahead and do that and tell me what you get. All right. So again, x bar means the average. So when you add all these up and divide it by 5, our average is 8. Okay. All right. So, all right. So I'm going to look at the first column. So, I don't know why it keeps doing that. So xi means the numbers that are given to you that are listed. So we have these numbers. Again, order doesn't matter here. So I'm going to list them. We have 9. Use a different color here. Okay, we have 9, 7, 6, 10, 8. Okay. And what does it want us to do with those numbers? Subtracted by x bar, by the average. So we're going to take 9 minus 8, 7 minus 8, 6 minus 8, 10 minus 8, and 8 minus 8. Okay. What do we do with that? Well, let's go ahead and calculate the result of that. So that's going to give us 9 minus 8 is 1. And what does it want us to do? It wants us to square it. Okay. 7 minus 8 is negative 1. Square it. 6 minus 8 is negative 2. Square it. 10 minus 8 is positive 2, square it. And 8 minus 8 is 0, square it, excuse me. So notice that I put parentheses around the numbers to let the calculator know that I want to square also the negative. Sometimes if you put like, say, -2 and square in the calculator, it'll say the answer is -4, which is not true. I mean, it's true here. But in order to square both, you want to do a parenthesis, so that will make it a +4. Okay? All right. Okay, so then once we do that, we're going to calculate a result. So 1 square is 1. -1 square is +1. -2 square is +4. 2 square is 4. And then 0 square is 0. Okay? What am I doing? I'm doing this top part here. That's what I'm working on right now. What I did, this chart here is representing this top part. I just broken it down so it's easier to read. Okay? So that's what I'm doing. Okay? So remember, this E means sum. So once I get the results here, I'm going to add them up. Okay? So again, remember this symbol here, it's not little, is E, a summation. That means you add them up. So I'm going to add those up and we get 10. Okay? All right, so we have the square root of 10. Okay, that's what we got for the top parts. And all this work that we just did, that's representing 10. And then we're going to do n minus 1. So n is the number of items or the total items we have, which is 5. So we're going to take 5 minus 1. Okay. So then we take the square root of this. So 10 divided by 4. So I would do inside first. So I would do 10 divided by 4. You'll get a decimal answer, and then you take the square root. And once you have that, go ahead and tell me what it is. Okay. So when we put this in the calculator, so again, you want to do inside the calculator first. 10 divided by 4, you'll get a decimal answer, and then you take the square root of that. Okay, so when we do that, it says to round to 2 decimal places, so make sure you pay attention to that on the test, and that gives us 1.58. So that's the standard deviation here. Okay, so this is our standard deviation. Okay, so as I mentioned, this problem is missed a lot. So I'm going to give you another problem similar to it so you can do it on your own. Okay, and then once you calculated it, go ahead and post that on the chat box. Okay, so down here it says find the standard deviation. You have 12, 13, 15, 14, 16, 20. These are the ages of people that went on a camping trip. Okay, and we want to find the standard deviation of that. All right, so we wanted to find the standard deviation of these numbers below. So hopefully you attempted that. So to save us on time here, I already did that work and I'm just going to post it here. Okay. All right, so hopefully um, you should have received 2.83 as your answer for this particular problem.